Hi, I'm Rich with insideHPC. We're here at ISC'13 in Leipzig, Germany, and I'm at the Obsidian Strategics booth with David Southwell. So who is Obsidian Strategics? What do you guys do?
Thanks. Well, Obsidian Strategics is an 8-year-old company. We've been doing what we do primarily for the US military, and now we're branching out into other spaces, and we do value-add capabilities for the InfiniBand protocol.
Okay, so how did you get your start? Then you were working with the DoD on special projects?
Right. So InfiniBand was created at the turn of the millennium, and it was designed as a supercomputer interconnect first and foremost. And the US military had a requirement for very high efficiency, very long haul communication. And it turned out that the supercomputer protocol, surprisingly, had the ingredients to make a very efficient transport. But it was range limited at that time to 17 meters. So we were in a position to develop very rapidly a technology which we brand as Longbow, which provides long-haul InfiniBand. So we transparently range extend InfiniBand over standard optical wide area.
Okay, so what are you showcasing here at ISC then?
Okay, so for the first part of our product rollout, we stayed at 10 gigabit speeds. InfiniBand, of course, climbed very quickly to higher and higher speeds. We were always constrained by the affordability of high performance wide area connections, which limited us to 10 gig. Mm-hmm. Now, we're recognizing that QDR and now FDR are on the market. And at this show I have the C400 Longbow, which is our first 40 gigabit product.
Well, what does that device do?
Okay, so it's really very simple. It's, as far as the InfiniBand fabric is concerned, it's a 2-port switch. One LAN port, which in this case is a QSFP 4X QDR, 40 gigabit port, and a wide area port. Used as a bookend to a wide area connection, 2 Longbows together look like two 2-port switches, 2 bumps in the wire, and they can seamlessly attach remote InfiniBand local area networks together.
Even though they might be miles or hundreds of miles apart?
Or thousands of miles.
Or thousands of miles.
Right, so this is a global interconnect technology. This particular device uses a hybrid wide area scheme rather than using a pure 40 gigabit wavelength, which is still, although it's available, it's expensive and it's not readily available in many areas. We have used instead 4 10 gigabit wavelengths, which usually would be mapped together on a single fiber using something like this device, which is a passive optical wavelength division multiplexer, which is another way of saying we can put 2 QDR 4X links through a single common fiber pair.
Well, that's well and fine. I mean, it does that well. Is it a one-trick pony, or does it do other things?
It does do a few more things, and in fact, Obsidian sees itself as a company which backfills the basic switch and HCA businesses that Intel, Mellanox, and IBM have with other features that make InfiniBand more deployable at scale. So if you're in one room and you're a single vendor supercomputer bought all in one go, managed by one organization with one set of users, you may not need other features which the Ethernet world has had for multiple decades, and really are table stakes for taking InfiniBand into HPC at exascale and also InfiniBand into enterprise. So features such as security are critical. Once you take InfiniBand outdoors, you create the problem of security. So we realized this early on. In the military case, our X-series devices are designed to work with third-party Type 1 encryptors. Our E-series product is designed to work with embedded encryption, and we've extended that capability to the 40 gig node. Oh. So this does AES 192 GCM, full line rate, no latency penalty. These are very low latency devices. And also SHA-1 authentication. If you have secure data that needs to be protected, the encryption on the wire is essential. Many folks who perhaps don't care about their data don't realize that a high-capacity pipe like this right into the core of your supercomputer also represents a security threat from the point of view of the infrastructure. So the authentication in the hardware enables man-in-the-middle attacks to be detected. So it's a way of securing data and the infrastructure.
Okay. So that's that piece. But security.
Right.
What other suitable applications might there be for something like this?
Okay, we like to think about the applications as a function of the distances that you're covering. So the latency through our FPGA here is around 500 nanoseconds. That's your port-to-port delay. Unfortunately, we can't do much about the 5 microseconds per kilometer, which the speed of light in glass gives us too. So up to a certain point, applications such as supercomputer expansion are viable. In fact, we have one of our customers, NASA, is expanding or has expanded their Columbia supercomputer by attaching 10,000 titaniums to 3,000 more through a 1-mile link using 80 gigabits worth of Longbow. That's actually low enough latency. You get 10 microseconds user space memory to user space memory through the entire chain. That's low enough to run MPI over a mile. So that's nice, but at a certain point the speed of light gets in the way and you don't want to run MPI over the continent. The next stop for applications would be at the 50 or 60 kilometer mark. These are ballpark numbers. And that would be for synchronous storage mirroring apps. And that's really speaking to, in the enterprise space, disaster recovery. Beyond that, you have to go to asynchronous applications just because of the flight time. So large scale, large data, bulk migration with very high wire efficiency. InfiniBand's lossless flow control, which the Longbows extend, allow you to achieve very high throughput efficiency even over very high bandwidth delay product links. Other applications which our customers are using these products for include remote visualization, where you can get away from the noisy clusters that are driving the visualization and have peaceful thoughts in front of beautiful quiet screens.
Well, you make a good point. I remember from my days at Cray, they taught us that the speed of light will travel 1 foot, but that takes a nanosecond, right? So, you know, multiply that out by miles, and suddenly...
40 gigabits, speed of light travels 1/4 of an inch.
Wow.
And across the Pacific Ocean, there are many 1/4 of an inches.
Yes, many.
So a lossy flow control scheme like TCP/IP falls flat.
Yeah.
And InfiniBand is essentially insensitive to distance.
Okay, well, what about routing?
Right, so another major plank in our value-add portfolio is routing. Most systems today are running single subnets in the InfiniBand network. There are problems with that. One of them is, the most immediate one is perhaps lid space exhaustion. You can only get so many nodes in a subnet. But before that limit hits, there are stability and performance problems. And in the enterprise space, there are obviously political or security problems. For example, you can't imagine a stock exchange running an InfiniBand cluster for its matching engine, sharing a subnet manager with a healthy hedge fund that's trying to make the best trade. It's a non-starter. So there needs to be isolation at political demarcation points to isolate the management, and that requires routing. Now, routing was included from a hardware perspective in the original draft of the InfiniBand specification. Unfortunately, the authors of the InfiniBand spec must have been a Friday afternoon. They tailed off before telling us how to build subnet managers that can talk to each other. We see routing as critical to seeing InfiniBand penetrate enterprise and also very large-scale InfiniBand installations. So there are two pieces that are needed, and we provide them both. The first is hardware that can do native InfiniBand routing. This means matching the GIDs to the lids using matching engines and providing the real-time mapping at low latency in the hardware to provide that mapping to allow multi-subnets. The second component is the subnet manager, and Obsidian has an initiative that we are expecting to be able to announce very shortly to do with our BGFC subnet manager, which is a completely redesigned software which handles, among other things, subnet management across multiple subnets.
Very cool. Well, so Obsidian Strategics, right, here you are. How do you reach the market? I mean, you have distributors and partners. How does that work?
Okay, so from the beginning, we've been somewhat aware that we do not, for most customers, represent a turnkey solution. We have a component which usually requires integration. Now, the exception would be the more ambitious of the rocket scientists who are actually building these things themselves, but generally we go to market indirectly. In the enterprise space, IBM is reselling our technology in certain configurations, and we are certainly keen to work with integrators who would like to add this sort of technology to their capabilities portfolio.